Hey Jim, can you help me with some math?
Sure, John.
I don't understand this exponent rule. I guess I'm supposed to add the exponents. But why?
Yeah. Okay, I can explain this to you, John. I can make this real simple. Okay, I guess I'll write in the color black. What is 2 squared times 2 cubed?
Oh, okay, I can do that. I will write in the color green. 2 squared is 4, 2 cubed is 8. 4 times 8 is 32.
Yeah, exactly. That's the correct answer, John. All right. Okay, so check this out, though. I'm going to show you a second way that you could do this problem. You can add the exponents. Seriously, this works. So you have 2 plus 3 in the exponent, right? So this is 2 to the 5th power, right? Do you know what 2 to the 5th power is equal to?
I don't know. Can I use a calculator?
You know what? Sure, why not?
Alright, cool. 2 to the 5th power. Oh, it's 32. We got the same answer.
Yeah, so we get the same answer, John, because adding the exponents works, right? Adding the exponents gets us the correct answer, right?
Yeah, this is actually kind of fascinating, because I always thought that there was only one way that you could do this problem. I thought that this was the only way that worked, but it's kind of cool that adding the exponents works as well.
Yeah. So John, let me show you why adding the exponents works. Like, let me show you sort of what's going on behind the scenes here. All right, so exponents mean that you're multiplying a bunch of times, right? So 2 squared is really like 2 times 2.
Yeah,
And 2 cubed is really like 2 times 2 times 2.
yeah,
So we got a bunch of 2's here that we're multiplying. How many 2's do we have?
5, right? Yep, we have 5 2's.
So can't I technically write this as 2 to the 5th power?
Oh, oh wow. I actually understand this. You wrote 2 to the 5th power up here, and you've got the 5 in the exponent from adding the previous exponents. Okay, I understand this. Adding the exponents works because it's like counting the 2's that we're multiplying. Adding the exponents is like a super fast way of counting up all of our 2's.
Yeah, exactly. That's totally correct.
Okay, I understand that. But whenever I see people talking about exponent rules, generally there's letters involved. So, so how would I do a problem with letters?
Yeah. Okay, we should talk about that. Yeah, so what would you do if you had like x squared times x cubed? Well, it turns out adding the exponents still works here, right? It doesn't matter that there's letters now here. Adding the exponents still works. So yeah, you end up with x to the 5th power. And that's like your final answer. You can't simplify that anymore. So yeah, x to the 5th power, that's your answer.
Okay.
Okay. But let me show you why this works, even though there are letters involved, right? It's going to look very similar to what we did here, but I'll show you it anyway.
Alright, cool.
So think about it. You know, as I said before, exponents mean you're multiplying a bunch of times, right? So x squared is like x times x,
Yep,
and x cubed is like x times x times x.
yep.
So we got a bunch of x's here that we're multiplying, right? How many x's do we have?
5, right? Yeah, that's 5.
So can't I write this as x to the 5th power?
Oh wow. That actually makes sense. You wrote x to the 5th power up here, and the 5 in the exponent came from adding the previous exponents. Okay, I understand this. Adding the exponents works because it's like counting all the x's we're multiplying. Adding the exponents is like a super fast way of counting up all of our x's.
Yeah, exactly. That's totally correct.
Okay, okay, that's interesting. So adding the exponents works if there's a number here, but it also works if there's a letter here. It doesn't matter.
Yeah, so it works, yeah, when there's letters involved. Because think about it. Remember, letters in math are supposed to be numbers, right? Letters are supposed to be numbers that we don't know. Letters are supposed to be unknown numbers, right? So actually, when you think about it like that, it kind of doesn't seem all that surprising that adding the exponents works here, because there's really not like a huge difference between having a number here like this and having a letter. The only difference is that like when you have 2 here or whatever, that's like a specific number, and here this could be like any number, right? So like, the same rules that work for numbers are going to work here. So really when you think about it like that, it actually doesn't seem all that surprising that adding the exponents works there.
Oh, that makes sense. Wow, I can't believe I actually understand this exponent rule now. Thanks for your help, Jim.
Glad I could help, John.